Alright, now that we've learned how to evaluate trig functions using the information from the unit circle, we're going to take that information and that knowledge that we used in applying that to pretty much trig functions for any point on any given circle or any point in the coordinate plane. Now, the difference here is that the radius may not be 1, could be greater than 1, and based off where the point's given, we may be required to calculate that radius. The other thing too is that obviously the point could be in any one of the quadrants in the coordinate plane, and so we're gonna have to figure out by the ordered pair given which parts are positive and which parts are negative, and depending on which quadrant it's in is also going to tell us whether the trig function is positive or negative. Now you can see here in this concept box that we have basically rewritten the trig functions in terms of r as opposed to in terms of 1 like we had with the unit circle. So very important that you can put that together and understand that. Now, as you start to evaluate these trig functions in different quadrants, what will happen is you will start to see that certain trig functions are positive and certain trig functions are negative depending on which quadrant they're in. Now we have an acronym here called ATSC to kind of help you remember the quadrant and which trig function is positive. And so A for all, S for sine, T for tangent, and C for cosine. Of course, that goes 1, 2, 3 as far as quadrants are concerned. This is a concept summary kind of showing you all of that as well. So let's take a look at a couple sample problems. Now, I'm hoping at this point you've had the opportunity to try sample problem 3 and sample problem 4. So I'll just go ahead and work through it with you and demonstrate these problems. So we'll start by pointing out the directions. It says to find the value of the 6 trig functions. Now the value, when it asks you to find the value, what we're basically asking is for you to evaluate the trig functions. And if you remember, evaluating the trig functions means just setting up the ratios for all 6 of them. So let's go ahead and first of all, in order to do that, we've got to have our given parts, and of course we have a point here that is going to create an angle that lies on 5, negative 12. So the point 5, negative 12 is on the angle, and of course that means that this had to have gone around all the way around here to stop to that point. Now what we're going to do is we're going to actually use the given reference angle coming back there to set up our triangle. So that reference angle is going to be what we're going to evaluate our trig functions off of. So when we look at this, we know that we had to have come over 5 on the x and then down negative 12 for the y. Now we need to get a radius. Now if you were pretty good at geometry or you remember Pythagorean theorem very well, you should have hopefully learned some Pythagorean triples, and you would recognize that 5, 12, and 13 is a common Pythagorean triple. Of course, you could always use the given equation that was for a radius, and of course, if you work this out, we would have a radius of 13 from that information as well. Now that we have all 3 sides, we can start to set up our trig functions, and of course we remember that we can either use the concept summary on the previous page, or we can just basically use our knowledge of right triangles here. So we can say that the sine of theta is equal to opposite over hypotenuse, and so in this case that's negative 12 over 13. And then we will just continue that process for theta all the way around with cosine and tangent. And then of course we need the other 3, so we need the reciprocals, and so we would just simply reverse, and of course that negative goes with the 12, and of course in fractional form it doesn't matter if it's in the numerator or denominator. And then we have the secant of theta, which is 13 over 5, and then the cotangent of theta, and that's going to be 5 over negative 12. And so there are our 6 trig functions based off of the 0.5 negative 12 being on the terminal side. So that is a basic problem using our understanding of the trig functions on a circle. Okay, so let's take a look at sample problem number 4. Sample problem number 4 tells us that we have a terminal side in quadrant 3. So they didn't give us an exact point, but they did tell us where the terminal side was, and we knew it was in quadrant 3. And of course we're going to use the reference angle here to set up our right triangle. Now at this point I really don't have any other information except they told me that the sine of the angle is equal to negative 4 over 5. Now this is opposite over hypotenuse, and the hypotenuse in this case is being represented by the radius, and so I know that that's got to be the positive part of it. So if I think about sine and what it's representing, it's opposite of the angle theta, so that means that this has to be negative 4, and the hypotenuse has got to be the positive 5, and that's my radius. Now again, we could use the Pythagorean theorem here, and I would know that through my Pythagorean triples that 3, 4, 5 is a popular Pythagorean triple. But in this case, since I know that we're going into quadrant 3, I know that my x value is going to have to be negative and my y value is going to have to be negative. So this is actually going to have to be a negative 3 to get that. And so we've now found the necessary parts of the triangle, so that's going to help us find the remaining parts of the remaining trig functions and their ratios. So if we want to find the value or evaluate the remaining ones, cosine is going to be adjacent over hypotenuse, and then tangent is going to be opposite over adjacent, but since we have two negatives here we can cancel those out, so that's technically going to be 4/3. And then of course we have the reciprocals. And we've evaluated all of the 6 trig functions, giving the first trig function. So a couple examples there of using the unit circle, and many more possibilities for problems using that. So